Okay, in this video, let's take a look at how to solve the limit of this inverse tangent function. So for the first step, let's analyze the inner function of 1 over x. So we know as x going to 0 from the positive side, it means we're approaching 0 from the right. And x becomes a very small and positive value. Our 1 over x will become a very large and also positive value. So our 1 over x goes to positive infinity. Okay, for step 2, let's understand the behavior of our inverse tangent function. And you know the u here is just the 1 over x. So to avoid confusion, we're using a different letter u instead of x here. And to make it more clear, let me graph the inverse tangent function here. So we know tangent x function is a periodic function. However, the inverse tangent function is a bit different. Inverse tangent function is not periodic. And here are some of the information we can get from the graph. So for inverse tangent function, our domain, which is our x value, can be from negative infinity to positive infinity. And our range, which is our y value for inverse tangent x, can be negative pi over 2 to pi over 2. So negative pi over 2 and pi over 2 here are called horizontal asymptotes, which means your function will get infinitely close to that line but never touch it. And we can also get from the graph that as u goes to infinity, tangent inverse tangent of u goes to pi over 2. And as u goes to negative infinity, inverse tangent of u goes to negative pi over 2. Okay, since now we understand how inverse tangent function behave, let's plug in to our original equation. Okay, so let's substitute 1 over x back to the inverse tangent function and see what we would get. So now we know the limit as u goes to positive infinity, the inverse tangent of u goes to pi over 2. Now let's plug in our x. So we know here u is equal to 1 over x. Therefore, our original equation would also be equal to pi over 2.